The next non-homogeneous higher order equation is identified as the second order derivative of y minus 4 times the first order derivative of y plus 4y is equal to negative 2 cosine of 2x. We can see here that our g of x is trigonometric in nature, and hence we are going to use the specific y sub b for our g of x being trigonometric. But nevertheless, the general solution of this equation is expressed as y is equal to y sub c plus y sub b. Y sub c is a complementary solution of this given equation where the right-hand side, or the g of x, is equal to 0. Or in short, if our given equation is homogeneous. So we're going to use the same processes in solving homogeneous equations pertaining to our left-hand side being equal to 0. Our y sub p, on the other hand, is known to be the particular solution once we take into consideration the correct coefficients for a certain y sub p that we are going to use for this process. Refer to the table below. We can see that for the 5th and 6th row, we have trigonometric functions being our g of x, and any of the two will have the same y sub p, but of course, our given g of x here is also in cosine. We'll be using the form of y sub p for our 6th row, but it's still the same as the 5th row. You have here a cosine of your angle. Our angle here is 2x plus b, and then sine of the same angle 2x. Later, we are going to solve for a and b coefficients to come up with the correct y sub p to be paired with our y sub c. So in the meantime, let's start with y sub c. That would mean let's come up with the equation of this left-hand side using the differential operator d. So you will have here, this is the form f of dy is equal to 0. So you will have here d squared minus 4d plus 4 times y is equal to 0. That would mean our auxiliary equation is expressed as m squared minus 4m plus 4 is equal to 0. The next thing is to identify the roots of this given auxiliary equation, so you can use different processes. And since our auxiliary equation is quadratic, you can also use the quadratic formula. But since I believe this is already a perfect square trinomial, I can just simply factor this into binomial expressions, or the same binomial expression multiplied to each other. You will have here m minus 2 and m minus 2 is equal to 0. If you're going to multiply them, you will come up with m squared minus 4m plus 4. In short, our first root is equal to positive 2. That is also the same as our second root. This means that we are going to use the general solution if we have this, repeated real roots. Talking about the solutions for homogeneous equations or homogeneous higher order equations. So the form for y sub c, following the general solution of situation where our roots are real and there is repetition, you have here e to the power of mx times c sub 1 plus c sub 2 x. We only have until here because we only have two repetitions, or multiplicity of 2 for our root being 2. That would mean our y sub c is e to the power of your root 2x times c sub 1 plus c sub 2x. You can also multiply that, but I believe this is already okay. So we'll have it like this as our final solution, our final y sub c rather. Okay, so we are done with y sub c. Let's proceed to our y sub p. Our y sub p will use this form, but take note that we have first order derivative and second order derivative of y. So we are also going to take the first order derivative y sub p, to which we're going to substitute later on our original equation together with the second order. And take note that we have two terms here, and we have trigonometric functions where our angles are also not just equal to x, but it's 2x, so we're going to use a chain rule. So the first order derivative of your first term is just a, times the derivative of cosine 2x is minus sine 2x, times the derivative of your angle 2. That's chain rule. Plus b, the derivative of sine 2x is just cosine 2x, times again the derivative of the angle 2. In short, your first order derivative of y sub b can be written as minus 2a sine of 2x plus 2b cosine of 2x. This will be substituted later to our first order derivative of y. Now, we still have the second order derivative of y. So let's look into the second order derivative of this. So you have your second order derivative of y sub b. So taking this again as constant together with this, so you simply follow the same process earlier. So minus 2a times the first order derivative, or the derivative rather, of sine 2x is cosine, that's positive, times the derivative of our angle, which is 2, plus 2b, the derivative of cosine 2x is minus sine 2x, times the derivative of the angle, which is again 2. So the simplified form of that will have this form here. So that's minus 4a, if I'm correct, minus 4a cosine of 2x. Okay, plus, I don't know, minus 4b, because we have negative sign, sine of 2x. So with this now, we have the second order derivative. We have the first order derivative here. Okay, and we will have here the y sub b, which will all be substituted in our general equation. So please look into this. You have the second order derivative minus 4 times the first order derivative plus 4y is equal to negative 2 cosine 2x. Cosine 2x. So we simply change the second order derivative to this, our first order derivative into this, and of course our y sub p earlier already identified as this. So let's look into this step by step. So this is our first form. So minus 4a cosine of 2x minus 4b sine of 2x minus 4 times the first order derivative of y sub b, negative 2a sine of 2x plus 2b cosine of 2x plus, let me place here at the bottom, plus 4y, but it would be y sub b, this one here from our table. So just simply copy that, a cosine of 2x plus b sine of 2x. Okay, these are all equal to negative 2 cosine of 2x. So solving for the coefficients a and b to come up with the correct y sub b, we'll have this next processes. Please bear with me. You have minus 4a cosine of 2x minus 4b sine of 2x. This will become plus 8a sine of 2x. This here minus minus 8b cosine of 2x. Then you have here plus this one here 4a cosine of 2x. Then you will have plus 4b sine of 2x. These are all equal to minus 2 cosine of 2x. Next part is to combine the coefficients of the same trigonometric functions. You have your cosine here, another cosine here. So you will have here minus 4a minus 8b and plus 4a of cosine 2x. And for sine, you will have here, let's just simply use plus in the meantime. So this is for your sine and sine here. So minus 4b plus 8a plus 4b of sine 2x. These are all equal to minus 2 cosine of 2x. Sorry, that's 2x. Okay, so this of course be simplified. So you have minus 8b cosine of 2x, and on the other side is also be simplified, plus 8a sine of 2x. These are all equal to minus 2 cosine of 2x. This would mean that this function with cosine would be equal to this, and since there's no sign on this side, automatically this will be equal to 0. Here is what it will look like. You have minus 8b cosine of 2x is equal to minus 2 cosine of 2x, and on the other side 8a sine of 2x is equal to 0. So for this, dividing negative 8 cosine of 2x to cancel this to get your b. You also be dividing minus 2 cosine of, minus 8 cosine of 2x. So you have negative 2 divided by negative 8, so you have positive 1/4 for your b. But for your a, automatically this is equal to 0 because that's the only value of coefficient which will make this entire form equal to 0. So with that, we already have our value for a and value for b. So our y sub b, which was already given as a cosine of 2x plus b sine of 2x, substituting all of the values, you will have 0 cosine of 2x plus 1/4 sine of 2x. That would mean our y sub b is just positive 1/4 sine of 2x because this is actually equal to 0. So we now have our y sub b. And our entire solution, as indicated earlier, is y sub c plus y sub b. So we simply combine them. Take note of your y sub c earlier with repeated real roots. So you could have it like this. E to the power of 2x, c sub 1 plus c sub 2x, then plus your y sub p, which is 1/4. That's 1/4 sine of 2x. This is now the final solution of the given non-homogeneous higher order equation, considering that our g of x is trigonometric. Thank you very much for watching.